So in 3.2, we look at another way of displaying association between two variables, only this time instead of a contingency table, which is good for associations between categorical variables, we're talking about scatterplots, which is a way to display the association between two quantitative variables. So a scatterplot is a graph where you take your x variable, which is usually your explanatory variable. You don't always know which is which, but often we have a sense for what ought to be explanatory. So we're saying that x, we think, is going to explain the changes we see in y. So y would be the response. You'll also sometimes see x referred to as the independent variable and y referred to as the dependent variable. And again, we don't always have a clear idea, but often we do. So when we make our scatter plot, every variable, every individual has a measure of both x and y associated with them. So if I picked out one of these x's, these represent data points. This one would represent somebody who had a relatively high value for x and a high value for y. Right? But the coordinates would be the particular values for x and y that this data point possesses. So we put up a scatter plot, and we want to kind of, before doing any calculations, this is kind of generally true in data analysis. You want to get a picture of what the data looks like and kind of do an overall assessment of what you're looking at before you start calculating things. So what we're looking for in our scatter plot is any clear relationship between the x and the y variable. So here I would say we have a pretty clear relationship that as x increases, so does y. And in fact, it seems to be along roughly a straight line. So we would think of this as a strong linear association between the two. And in fact, because the line goes up and to the right, we would call that a positive linear association. So this would indicate a line with slope that's positive, so it's a positive association. Moving on to the next example, this one is less clear, but there is an association that as x increases, y tends to decrease. It's not, because it's not as clear, it's hard to see for sure that it's linear, but there's no obvious curvature. So we would call this kind of a moderate linear association and a negative one, because as x increases, y decreases, or if you like, the slope of this line would be negative. Right. Moving on. This looks kind of like a random cloud of points. We would say that there's no association between x and y in this scatter plot. And what about going down along the bottom? Here, our scatter plot reveals a really strong association between x and y, but it's curved. Right? So this looks kind of like a parabola that's turned upside down. So as x increases, y increases for a while, and then it comes back down again. So that's a really strong association. It's not a linear one, it's a curved one. And then finally, we have a very strong association. Can't say it's negative or positive because it's negative for a while and then turns positive. It's not curved, but it's also not linear, right? So it's kind of like two straight lines pieced together with a sharp point here. Kind of might be reaching back a little bit, but this is similar to the graph of like an absolute value function where you have this sharp point at the bottom. But in any case, we would definitely say this is a non-linear association, even though it's a strong association. Right, now, if we have a linear association as evidenced by our scatter plot, right? So we've plotted the data, and the association appears to be a straight line, as in the first one or the second one here. Then it's appropriate to measure what's called the correlation between x and y. So this is got the symbol little r, and it measures how strong the linear association between two variables is. It's positive when the association is positive, and it's negative when the association is negative. It's a huge pain to calculate, so we're not going to do it by hand. We'll always rely on technology to calculate R for us. Now, R is always stuck between -1 and 1. So a perfect 1 would be a perfect straight line and positive association, a perfect positive linear association. -1 would be a perfect negative linear association. And there are a couple of small examples in the guided notes to give you a sense for what counts as what. Now, if we were just going to sort of eyeball these and go through and assign a value of R, this first one's probably like a 0.9. Right? That's a really strong positive linear association, so we would expect it to be close to 1. This next one is weaker, seems roughly linear, but it's negative, so something like a -0.6 maybe. That might capture the strength of that linear association. And then moving over here, no association would be an R equals 0. And here are the ones that are, tricky is not quite the right word, but just something to kind of test your understanding with these last two. The curved association here is really, really strong. So that is a really highly associated pair of variables. But still, because R only measures the strength of a linear association, this would be an R equals 0 also. The association here is super strong, super clear, not at all linear. So R would be 0 there. We have the same phenomenon in this second one, even though this is not curved. Really obvious association between the two variables, not a linear one. So this one is also going to be a 0. All right, so scatterplot reveals the relationship between our variables. Now, you want to be careful to do that before doing any calculation, because the correlation, for example, only applies if the relationship is linear to begin with. So if you start off with a scatterplot and see that your scatterplot's not linear, there's no sense in calculating the R. All right, that's going to do it for this brief introduction to scatterplots and correlation. We'll typically let StatCrunch do both the graphing and the calculating for us. I will see you in class.